So far, we have covered very rudimentary basics of scripting. Essentially, we wrote a tiny script that echoed something to the screen, our hello world script, and then we modified it to assign the hello world string into a variable, and then echoed the variable out. So in order to make our scripts do interesting things, we need to get some logic structures. So the book talks about 4 basic logic structures: sequential logic, decision logic, looping logic, and case logic. Sequential logic, the commands are executed in the order in which they appear in the script. The first command is executed first, the second command is executed second, and so forth and so on. There is no logic in there to say, okay, only execute this command in these situations, because that's a decision, and we haven't talked about that yet. So here's an example of some sequential logic. If you look at this script, it basically runs those commands in that order. It'll run the first cut command, this cut command, it'll run it, then it'll run the second cut command, then it'll run this join command to create this file, and then it'll use awk to print the report it wants to print, and then it will remove all those temporary files it created. So that is sequential logic. It goes in order, it does every command. Most of the time, you probably won't be writing many scripts that consist of just sequential logic. Even if you write a script that could probably just consist of sequential logic, you may modify it to put some decisions in there. For example, you may think, oh, I'm tired of running this user mod command to create users, so I'm just going to write this script that I can run that will add a user. I'll write my own script to add the user and generate some things. So you can do that. However, there's going to be a situation where somebody's going to add the user without properly marking it in the ticketing system that they added the user. So then you're going to want to go add the user, and you're going to add the same user, and you're going to get an error message. Not a big deal, but you may, being the scripting expert that you are, you may determine that, hey, you know what, that was kind of lame. I'm just going to write a little bit of code in here to check to see if the user already exists. So then it checks to see if the user exists, and then it does some decision logic to say, if the user exists, print out the user exists. If the user doesn't exist, then add the user. So most of the time, your scripts will not consist of just sequential logic. Decision logic. This is where we get to make things more interesting. Decision logic allows us to execute certain statements based on a condition that we want to check. In this example, we're printing to the screen, what is your favorite vegetable? And then we're reading that into a vegetable called veg name. And in theory, the user will type in their favorite vegetable. I would probably type in, I hate vegetables. So what it would do is it would look at the results. It would say, hey, did they type in broccoli? If they typed in broccoli, it's going to print broccoli is a healthy choice because broccoli was what it was looking for. And it says, hey, did they type in carrots? And it's going to print out carrots are good for you. And then this last else down here, let me go back over here. Else's are what tells it, hey, if it meets this parameter, do this first thing. Otherwise, do this other thing. You can have ifs without else's, but if you want to have a default action, should the if not match, then you'll use else for that. So this says if the veg name equals carrots, then echo carrots are great for you. Otherwise, echo don't forget to eat your broccoli also. So should I have put in I hate vegetables, it would have echoed out don't forget to eat your broccoli also. And then it would have ended. You notice these phi's down here? Those are how you end a if clause. So in other higher level programming languages and either other scripting languages, we normally do that with curly brackets to enclose the logic that goes along with a particular set of if statements or loops. We use curly brackets for that in other languages. In the shell, we put a fi at the end of the if. So if you notice, there's 2 ifs in this statement. Here's if blah blah veg name equal broccoli. Right? We look down here. Here's the fi that goes along with that if. Here's the second if veg name equals carrot, and here's the fi that goes along with that. You also notice the code is indented. Each subsequent level of ifs are over farther to the right. This makes it easier for you to keep track of if you have the right number of phi's and whatnot that you need, and which else's go with which ifs. If all of this was over on the left margin, then it might not be readily apparent whether this else goes with this if, or this else goes with this if up here. So when you indent your code over, it makes it a little easier to read and determine what is going on. Looping logic. So decision logic, you want to execute a instruction set based on a particular criteria. With looping logic, you want to execute the same instruction set some number of times based on the criteria. The two types of looping logic we're going to talk about are for loops and while loops. A for loop will loop through a range of values. So you will use a for loop when you have a finite list of items that you want to execute on. And when I say finite, does that mean you need to know how many there are? No, finite means that the list begins and the list ends somewhere. And for each item in that list, you're going to execute the code. For example, in this code segment, it says for users in John, Ellen, Tom, Becky, Eli, and Jill, echo users done. So that's going to basically just print out the username. The for loops, the logic, you have for, you have this transient variable, I'll call it. This gets the value from the list. And then each time it goes through the loop, that value changes to the next item in the list. You start your for loop with a do, and you end it with a done, and you put your code in between the do and the done. So in this example, there's 1, 2, 3, 4, 5, 6 usernames. So it will execute 6 times. So a for loop is useful when you have a finite list that has a beginning and an ending. If you just want to do something, more for. Here is how you can execute a for loop at the command line. I do this all the time. For my hobbies in the for hobbies, do echo my hobbies done. So you can run a for loop at the command line in that way. Let's see what we do. I apparently deleted the slide for while loops. Did I delete the slide for? Yeah, I deleted the slides for while loops unintentionally. Let me go see if I can find that. First, let me close this, I guess. It won't let me open it if it's already open. Discard. While loop. Pretend like this didn't happen, because just tune that out for a minute. While loop. A while loop will keep going until a certain condition is met. So it says while continues to loop and execute statements as long as a condition is true. So in this case, it's while guess not equals red, do no, not that one, try again. So basically, it asks a question initially. Guess my favorite color. You'll read that from the command line, the entry, and then you will basically keep looping until they actually guess the right color. Yeah, that's what I'll say about that. We'll do some examples later. See what the next slide says. Case logic. Case logic is a quicker way to do a little. Usually these are used when you do some sort of menu system for users to tell you things. You could emulate case logic with a bunch of if statements, right? So in this case, we asked the user to enter their favorite color, and we read the color, and then we did this case statement based on the color. And then if it was blue, we echoed as in my blue heaven. If it was yellow, we echoed this. If it was red, we echoed that. If it was orange, we echoed that. If it was anything else, we echoed an error message. These end with double semicolons, so that's how the code knows where to stop executing. The case statement ends with case backwards, ESAC. So put that at the end of your case statement to be done with it. You could emulate this with a bunch of if statements. So basically, when you get to right here, read color, you could do if color equals blue, echo blah 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 phi. If color equals yellow, echo blah 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 phi. If color equals red, blah blah blah, echo whatever. So case statements, they exist. They can be useful in certain situations, but you could totally live without them if you just wanted to write a bunch of if statements. So I think that's all I wanted to cover with regards to the different types of logic structures. There'll be some more podcasts where I do some examples, so be sure you check back for those podcasts that I do examples in.